Welcome to Ecoblog, and I'm with Sarah in the Keel. Sarah, we're going to be discussing what subject?
Solar panels. What are they?
Okay, solar panels. So, easily confused, there are two different types of solar panel. One produces heat, hot water usually, and this is called a solar thermal panel. And the other type is a solar photovoltaic panel, and this converts the sunlight into electricity.
And which is best? They obviously have different properties.
Okay, there are a lot of different factors you could include in this. As a quick summary, I would say most people would probably be looking at it in terms of the economics to them as a householder. So they'd be looking at how much it would cost versus how much they would save. In other words, the payback time. But there are other factors as well. So if we just start with the payback time, we've got to a sort of a cusp point because of the price of the crystalline solar photovoltaics has come down so much that we've got to a cusp now where really, whether we're producing hot water or we're producing electricity, you could say that they're pretty much on a par. In fact, it's probably getting to the point where it's cheaper to produce the electricity. And there's a second benefit with electricity. We would term thermal energy or hot water is a relatively low grade energy form, whereas electricity is incredibly high grade. It's very, very versatile. You can use it for many functions. So in one sense, for a lot of people, it might be more convenient to be generating electricity. There's another factor to point out here though. With hot water, you can store hot water in a tank for a limited period of time, but you can store it. And in fact, the larger the tank, the more you can store. So some people choose to have a very large tank to make full use of their solar panels, and others have a more modest one and accept that they'll only be using about 25% of its capacity. Now with solar panels, you can store it, but then you'd need to have some sort of backup storage system. So you would either sell it to the grid, it's not really a storage system as such, but it allows other people to use it, or you have batteries which would store it for later use. And storage becomes an important topic, and we'll be discussing this in a later blog.
What potential does the island have for solar power?
Okay, so to give you an idea of the numbers, if the sun is shining on a square metre, it produces about 1,000 watts on that square metre. That's on a bright sunny day. And obviously it's producing that over time, and in the winter the days are shorter, and in the summer the days are longer. Overall, in the full over the full year, surprisingly, we can produce about 40% of what can be produced in the Sahara Desert, which seems much higher than you would expect. But we do have incredibly long summer days. In terms of actually that transferring to something useful, well, we have to realise that when we are converting the sun into something useful like electricity, we can't capture it all. We can only capture a percentage, and typically for a solar photovoltaic panel we can get about 12%. So we're only getting sort of really we're only getting a fraction of the potential. However, using that number and sort of taking the number of households we have, so we have about 37,000 households. We've also got industrial buildings. Now, if we put solar panels on the roofs of all the available buildings, and I'm choosing roofs because I don't want to be taking away the land from other purposes, and there are other visual aspects that come into it. So let's just say, let's use what we've already got, the urbanised areas we've already got, so the roof space. And let's say there are 35,000 houses. We've got perhaps an equal number of surface area of other industrial roofing. What can we get? Well, at the very maximum we could get from those buildings would be about a tonne of carbon dioxide per person offset. In other words, for each person on the island we would be offsetting one of the 12.5 tonnes that we produce every year.
So hang on a minute, you mentioned 12.5 tonnes there, but previously you've said 10 tonnes. What's the difference there?
Okay, these are estimates. The government estimates it at about 10 tonnes of carbon dioxide per person. They might not be including all the import of goods to the island and their carbon footprint. I'm not sure if that also includes an element of aviation fuel. The Friends of the Earth estimate on the Isle of Man is 15 tonnes per person. What I've taken is a number between those two values to get 12.5.
Okay, thank you.